Right, now we're getting into the proper guts. If you think, we've got ports. Ports have events on them, right? So you have a pressure port, pressure events are your port, your events. That's not really that convenient. If you feed that into something like a scalar, you want things like the key number for the key number to derive the node from, and you might want something like your to be event for that specific key. So the way that signals are expressed in the outside world is not that convenient for processing because they're grouped into signals. Inside the Python, remember this is not part of the fundamentals, this is just a framework. We have something called bundles, which is a processing graph. You have components and you plumb them together. And these components are written in C++, and the easiest way to write one is C-filter, which makes you a bundle component, which you just get start, stop, data. So it deals with all that for you. We have input data policies, which will get this data from your ports onto a bundle for you. And here we can see a bundle kind of being built. This is an output port. We have a splitter which terminates a bundle and puts the data onto output ports. We have a sine oscillator which is driving the output. These are all bundle components. Then we have an input which is driving the oscillator. And then we have the inputs. And here, you see these are the input policies, which we talked about before. Those are being created for these things by the input. The input actually acts as a factory for policies. Let's look at events. The input, let's go back here, vector input in this case. The root of that is a thing called the correlator, which it inverts the hierarchies. On the outside, we have signals carrying events. Inside a bundle, in a bundle, we have an event carrying multiple signals, which is the way you typically want to process it. You want a bunch of related signals all together, and they're related by the event ID.
So the correlator lines them up, basically.
The correlator does the lining up. And there are some rules. It's especially a one-to-one process. So if we imagine here, we've got a pressure input and a roll input on an agent, and we've got IDs 1 and 2 coming in here, and IDs 1 and 3. After the input, we'll have 1, 2, and 3, and the different things will have been distributed. On ID 1, we've got a pressure and roll signal because both of them have ID 1. On these other ones, we've only got the 1 because they're there. And this is what happens inside a bundle, and this is the domain of things like C-filter, which are bundle components. They get a whole bunch of signals. So each event found in C, when you get given event, you get an array of the ring buffer, the data queues, which you can do what you like with. Lots of bundles just don't actually process data. Things like key group, they just steer it. They just send it other places. So when they get events, all they do is create a new event and pass on the data buffers. So they don't have to touch the data at all.
So you don't have to use bundles. It's not like if you're dropping down to the C code.
No, you don't have to. No, they're not part of the lowest level EigenD agent API.
It's just a transform you can do if you want to have it in that form.
Yeah.
And it's a very convenient one. Usually you want to crunch data in this correlated form where it's actually by event ID rather than by signal.
Yeah.
And we have a growing toolkit of bundle components that do things like split bundles into two, aggregate them, merge them together, switch them on and off, that kind of stuff. Apart from things like oscillators and stuff like that. So, correlation, yes, the correlator, which is the root of the inputs, which lines up events with each other, decides which events are going to go together into down the bundle. It's the scariest piece of code in the system. Nobody goes into it without praying first.
And another point about the correlator is if you don't need to use it, so if you don't need to handle the data in that way, it's really best not to. It uses CPU, doesn't it?
Yes, I mean the event, this inversion process is not free. It's very convenient to use bundles, even if you're just routing data around, but it's not free, and it's probably best not to if you don't have to. Sometimes you've got to. The key group mostly is simple things that just clone data and switch bits on and off. But because it has to do it depending on which key, it does actually have to correlate all of the key signals with the key number signal in order to know what key, given yours, it can't steer a yaw signal without knowing the associated key signal, because that's how it knows what key it's on. So, if we're looking at how this correlation works, generally events are, you have primary inputs and secondary inputs. And here we're talking about how the scalar, it makes no sense. You don't do anything if you just get an octave, because what do? Really, the key number is the scalar's primary event. When I get a key, I create an output event. So, just an octave. If there's an octave there, it gets correlated with it and will get used. If there's no octave event there, maybe the default value gets used from that board instead.
So it's essentially a push concept, don't poll, and concept, right?
Well, all these events are coming in on the inputs. They come into the correlator. The correlator creates a bundle event which contains the data keys out of those things. That's pushed down through the bundle. So when I hit a key, the event is being pushed out.
Yeah.
After that, the data is flowing through the ring buttons, and nothing happens until I let go of the key, when the event end then goes down the stream. So the only push, the push is setting up this circuit, if you like, and then data flows through the ring buttons after that. It doesn't happen, because you can't push 2,000 times a second times however many things.
Running off your clock, normally you've got a clock running around that has to consume that data.
So, talking about key, yes. The key number is primary. The scalar can't do anything without it. And there is this distinction between primary and secondary events. And slight refinement on the model. The way the correlation works is because these events are actually, it's a dotted number. It's not just 1 and 2. It can be 1.3 or 1.4 or empty or something like that. The rules for correlation are quite simple. With a primary input, the event ID is usually the event ID coming out. So if I've got the key number coming in with ID 1, that creates me an ID 1 event.
It's a deliberate mistake on this, isn't it?
Yes, there is. No, well, sorry, that one should be a 2. Sorry. So here, because I've got 2 events coming in on my primary key input, I've got 2 events coming out there, ID1 and ID2. Now, they both obviously got key number channels coming in from the ID. But the bend, I have an ID1 and an empty one. Now, ID1 matches ID1 quite closely, so it will actually get the bend out of 1. For the ID2 event, there's no bend for ID2, but there is one for dot. And because that's a prefix, it will use that. So if you, as I've said, supposing I've got key signals, right? I've got my primary key number coming out when I hit the key. I've also got the pressure, roll, yaw signals as well. If I hook one of those into the bend key, it'll be a per key. Every key will have its own bend because the roll signals will correlate in with it. If I hook a strip controller onto the same input, that's doing a root event, and it will just apply to every key currently being pressed.
So dot is a root event.
Yes, it's how we show it, empty ID.
Good.
Yeah. And yeah, the real rule is that if it's a leading prefix on an auxiliary input, it'll apply to anything that it covers.
Can I just restate that so that I'm clear? The key specific pressure roll yaw takes primacy over a strip.
No, the fact that it's a strip is just that what matters is the event ID. Strips, because there's only one strip, you get an empty event, right? The keys, because
if we're looking at a bend, if I bend a key and at the same time I have another key pressed and not bending it, but I'm controlling the strip bend, is the strip applied to both keys, or is it only applied to the key that I'm not bending manually?
Only applied to the key that's not bending manually, because what the correlator does is it picks the best one for each input.
So an explicit is better than the...
Yes.
Yeah.
Yes.
one question. The IDs. So, what happens if I have two streams of data where the ID is just randomly not correlated in any way? For example, if I have two...
Well, the alpha has two strip controllers, right?
Yes, both of which generate dot events.
Yeah, they are special. That's not what I mean. What if I have two keyboards? And one keyboard is the main input, one is the other.
Right. Well, if you
press two keys at the same
if
time.
you connected them naively, then key one they would fight. If you get that only picks one, and actually an events aren't mixed, so one would actually block the other. One key is going to happen first. The next one coming in, because there's already an event in process with that ID, you would actually get ignored. So the first key one would work. The second key one would be ignored. If you press key 2 on the other output first, that would work. Only the first one would actually
I'm not sure I understand this.
work.
So one keyboard is the main input, and the other keyboard is the...
No, if you've got them both connected to the same thing,
Yes.
equally, then you can only have one ID at one time on a bundle with the same ID. Both at so if I hit key 1 on both keyboards, I've got two event 1s coming in on the same input,
Yes.
and it will only use one of them. It'll pick the first one, which will block the second one. So you'll only be able to use key 1 from each keyboard at the same time.
So the correlator is just using ID1 to mean ID1 and
Yes.
correlates all ID1s across
Yes.
all the inputs.
And it's not
And you're
mixed.
saying in order. Is that the order they're set
The
up?
first event comes in, will use up that event ID when the next one comes
When
in.
you say
Ask you the
first,
question, Jim. The only real problem with that is the fact that the keyboards share the same event IDs. Should they not have a prefix that stops that happening? Is it not some argument? This is something in flux, by the way, guys.
Yes.
I can think of reasons I would want it to have the same idea.
Yes.
Can you?
Yeah.
And there
like
are-
a chord here, and I wanted to...
There are also tricks, well, in later slides, there are also tricks you can play to deal with that.
I just want to know that I really understand this correct. So if I have pressure from one keyboard and you're from the other, and connect them this way...
Oh yeah, if you did that, because they're not going, yes, if you had pressure from one keyboard going in, then actually the key 1 yaw would control the event generated by the
Yeah.
other key on the other keyboard,
But
because they both have one.
the event IDs are totally not... I mean,
Well, no, they're
how
both.
does the correlator know that...
No, there's just one. It's just
They
looking
have-
at one. What's there is what
They're
it
the
sees.
same number.
They happen to be the same.
But why the IDs are not...
If they weren't the same, then pretty much nothing would happen.
Because the implementation of the keyboard agent actually decides to use the key number as the event.
Yeah, but that's just
Yeah.
we should.
Yeah, but they just show, they happen
It-
to be
it
the
may
same,
not in the
which
future.
means they happen to work in the same.
That's exactly
in
what I mean.
general,
If it's not true, then...
You're pressing two keys.
in general, related events have the same thing because they're generated by the same action,
Hardware.
like a keyboard or like pressing a key. And in general, you deal with often things like scalars or oscillators or something. An ID comes in, the same ID comes out the other end. So you know there is a kind of causality chain with the IDs. So you know the IDs are gonna work together. If they're coming from random sources, you don't, and that's
But
not.
this is important to know, the correlator. I mean, if you really have in the future, I don't know, a completely different from another company input that goes into EigenD, and they do the IDs with their keyboard or whatever, it's generated differently than...
This only matters when you connect two things into one input.
Yeah,
Yes.
in general,
Yes.
related things that are generated by the same event, like a key press, have the same ID because they have the same root cause.
Yeah, the problem here, Jim, is the fact that two different keyboards can generate the same IDs, which they probably shouldn't do. Really.
Yes,
It
okay.
depends. It
That-
can be an advantage.
No, that's
or
a
a
trick.
disadvantage.
No, that's yeah, it
Okay.
could. Yeah,
Your
but
correlator
it's
is an ID correlator, which
Yes.
is changing
Let's
streams
let's
into
let's
bundles.
let's keep
move on, 'cause
let's
this
keep
is
going.
something that's still in discussion.
Yeah,
internally for us
and
as well.
there's also more slides a bit later.
There's other stuff here.
I just want to know that I understand right. If I do this from two not correlated inputs, then something
Yes.
probably usually nothing good will happen. Nothing
So
interesting.
there
Well,
are.
no, you might get some interesting things. John's right about that.
Yeah.
Actually, yeah.
Yeah. But
It's actually
if by random you mean interesting, then
Yeah.
it's possible for connections to transform event IDs. This is partly related. There are two parameters called using and filter, which we are going to change. So then, yeah. probably.
No, they'll have new names.
Yes. Same thing, different names probably. You can have the using parameter. When an event comes into a signal, what it does is it puts that number on the front. So if I have event 1 coming in, it'll become event 1.1. And if I have event dot coming in, I have event 1 coming
The
out.
easiest way to think about this is like a channel through whatever you're doing, because you're creating these new.
So if I connected my two keyboards to the same thing, if I put using 1 on one of them and using 2 on the others, they would then have distinct event IDs. And then they would work exactly as you wanted them to.
So, in case you've not discovered this, some people have asked me that. This dialog, you get it in Workbench by using the edit tool and clicking on a wire. So you can get that to pop up. And if you've got a bundle of wires, it will give you all the wires.
We don't have a tutorial for it yet, because we're about to rename all these. Well, are we going to call them channels?
No, well, channels is a bit more. We need to do some possible
difference.
Semantic difference with
Yes.
that. Filter is the other end. If I've got a connection coming in, and if I put a filter of 1 on it, it will reject any event that doesn't begin with 1, for a start. It'll just get tossed. Events that do begin with 1 will have the 1 stripped off. So, for instance, if I took my two keyboards and using them into the thing, the events coming out would have 1 and 2 for the two different keyboards, and I could connect them on and pick out either of the two keyboards by filtering by 1 and 2 on the other end, if I wanted to.
I could even prevent the correlation in the previous example, for instance, if I want
If you wanted the strip to only attach
the strip for a primary pitch and then a fine-tuned pitch with the key, so I could use different sub-channel numbers for the strip and the pitch bend on the key, so they wouldn't be correlated to the same and it wouldn't be overwritten.
Yes. Okay.
Just going back to one of the agent suggestions, can that filter number be changed by some other agent? So coming back to your mode key,
Yeah, that'll be cool. They'll port the filter number, Jim, or is it?
No, it's a parameter for the actual
And
connection.
you can change your per canto, though, right?
Well, you'd have to disconnect it and reconnect it with a different thing. So it's set when you connect it. It's not dynamically
So it's not dynamic, it's made in connection time.
Things are not an agent before we
But on the other hand, it's only an RPC. You can disconnect it and reconnect it. You can do
But it'd be
that.
on the slow side, so
Yeah, it's not going to be a thing you want to be doing while you're playing.
Connections.
on the sort of cause of it.
Yeah.
When you make connections, you're building carrier channels and stuff. It's quite a slow process. And if you imagine a carrier channel being created, that might cascade through all the connections.
You might have hundreds.
These are basically polyphony. If I have 10 channels coming into a oscillator, it basically has to create 10 oscillators. And if create a new one, it has to create a new oscillator.
Something you do set up creation.
Well, it's something C-filter deals with you.
Yeah.
For
Well, it happens dynamically for you as well, remember, sometimes, so depending on how the agent's doing.
An agent might use a
sample
pool,
oscillator.
or it might just statically allocate each oscillator for each input channel. It's kind of up to me.
Are you at risk of that kind of thing and interrupting your performance?
Well, that's why
there's too much
it's a
of it
slow
going on?
process, so
It's
it
why
only
you have a
happens
high
in a slow
force
thread.
So you rely on the thread scheduler to keep your music going.
That's why, I mean, the fast thread is very high priority, real-time priority, or close. It's not, it's a very high priority normal thread, usually. It's a minefield, that. It's different on different boxes, but it's not allowed to block or anything like that. It's not allowed to malloc, it's not allowed to take a mutex. Anything that might block and cause it to be swapped out. Theoretically, every object that it ever touches should be pinned into memory with mlock or whatever the equivalent is on a different box, so that it can't page fault. That's that's the goal. It's very hard to enforce that. But, there's some good tools on the Mac. I haven't found anything good on Windows yet to spot page faults. But, if anybody knows any, then I would love to hear from them. Sharp on the Mac does it. So here, just to kind of an example of what we've got. We've got a vector input here and 2 ports. Vector input creates the policies. Vector policy is our primary input policy. Vector policy events create events down the bundle. Merge policy are the other ones that get merged onto any event. So, for instance, you only get an event down the bundle if it comes in on a vector policy input. events coming in on merge policy. If there's an event already in progress that's created by the vector policy, it will get merged onto it, otherwise it'll get ignored. And of course, things can come and go. It can get quite hairy inside in the correlator, because you might get the vector event coming up first, then the merge one. Might be the other way around. And it tries to do the right thing. There are a whole bunch of other policies as well. There are variations on merge policy depending on exact behaviour. Usually there are all sorts of weird cases, usually to do with when events come and go as to what you want happening. Normally when the vector event goes, that's it, that's the end. Sometimes you want other things to happen. A hold pedal input is really a merge because it's an auxiliary data, but as long as the hold pedal's down, you want it to prolong the event. So there are variant policies to deal with that kind of case.
So what does it do if I define various inputs as vector policies?
Then an event on any of them will create an event.
Okay, so it doesn't wait until I have vector inputs on all of
No,
these?
any of them.
And the others will act as merge, right? The other vectors, if you have several vector policies and they are being used at the same time, the first one will kick off and the rest will become merge.
Yes, yes. Okay, keep this quite quick. I'm going to step up a bit. There are two basic kinds of data in system: ISO data, clocked data versus unclocked data, if you like. If you think of MIDI, MIDI is unclocked. It's just events. They happen when they happen, and they get passed down. Isochronous data is audio. Basically, it needs to be generated. If I've got a 512 buffer size at some given rate, I need to create one of those buffers and it needs to happen. And our signals can be either, and it's a bit of a pain in the arse because the two are really quite different, and trying to treat them as the same does generate some sort of tension. The main thing is each vector input, really, you have to tell it in advance whether it's an aniso input or an ISO input. If it knows that, it can generally convert one to the other. But you can only really convert if you know the characteristics of what you're converting to. It's very hard to react to something. That's something the system's not good at and can possibly get better at. I'm not going to go into that too far.
So is the majority of the data inside EigenD itself?
Basically only audio outputs, and the only other thing we use as ISO that isn't audio is actually gain. Envelope generators generally generate ISO gain because you get sample accuracy on the envelope there, rather than an ISO thing.
Everything else is okay.
Yeah. There are parameters to the various policies that vector input creates where you can actually supply the conversion mechanism it uses. Particularly if one useful thing, if you've got a volume input, it might be an ISO input, like a gain input coming from an envelope. But if you're controlling it from slow, you can say that the conversion to ISO should happen through a given low-pass filter to only allow certain slew rates and things.
You'll get artifacts otherwise coming into your audio, which will have step functions going into the audio mixing. So there's signal processing issues connected with that you have to be aware of.
And there are a few other kind of odd policies, and generally you don't really need to know about those. If you find the need for them, you'll probably understand where the code that comes from. At the moment, you can just say true or false for ISO or aniso, and you'll get a default converter, which generally is okay. I talked about these other policies. When an event is created, in a normal kind of event, the correlator creates an event, the primary event goes away, so the event end is sent downstream. Whatever's downstream might well keep on going. If it's an envelope generator, it goes into its release phase at that point. The correlator knows this, there is a back channel up bundles. And there are different things that you might want. If another auxiliary event comes in, do you want it to be tossed away? Do you want it to join onto the event that's still running in its linker phase? There are lots of variations and different things that can happen, and usually they're different for different agents. It depends on what the agent does as to the right
An
thing.
example of that, if you were writing a physics system which has stored energy, every event that comes in may drive that energy in the oscillatory system, and you want to then reattach to that oscillating system with a new incoming event later on, and you need to know that it's still there, perhaps upstream, in order to be able to do that. So there have to be these kind of mechanisms whereby which you can know about events hanging around.
And an easier example is the whole pedal input, where that's an auxiliary input and it needs to prolong the event. So there are various other policies. There are default policies that, or merge policies that don't supply a default value. There are some that do different things depending on whether they're connected or not. Oscillators use one of these. If an oscillator is not connected to anything typically, no connections, it actually acts as a free running oscillator. So the frequency and volume, it'll be generating one event on its output with a sine wave on it or something like that.
Driven by the static value.
Driven by the static value. As soon as you connect it, it changes character and suddenly it becomes a slave to whatever's created.
So I can ask my input port whether something's connected and do some value generation inside my agent
Yeah,
code.
yeah. But actually what happens, I mean, the policy here, which it does, actually what happens is that the correlator creates an event going downstream to your oscillator with these values on it, and that event gets cut off when you connect it, then connect it to something. So you don't have to write the oscillator any differently to do that.
Did this somebody wanted an LFO agent at some point? You don't really need one, by the way. You don't need one oscillator.
You could use the sine oscillator.
Yeah.
So you've got a bundle, it's got events on it, and you can output them. Obviously it's the reverse process in that an event has signals in it and you just need to split them out onto different ports for each part. So it's exactly the opposite of correlation, but much easier. So you've got two events with signal 1, signal 3, these different ports, and you'll see that they're kind of spread out as you'd expect. It's a pretty straightforward process. There are no policies involved, it's just quite a simple thing. So you have an output, this is the port. You use a special output port, which has its own kind of policy built in, and then you just use a bundle splitter, give it the outputs, and if it's on. So this is a port that's going to be outputting the value of signal 1 from this bundle. True, false, again, ISO versus uniso.
True as ISO.
True as ISO, yes. So, I mean, this is an audio output, so it is ISO. And generally, an output is another bundle component. You drive it in the same way. Gert will be dealing with that kind of stuff. Output is very easy. So one last thing. We briefly hit on some processing. You can do processing based on either push model processing, where you data gets pushed to you as it happens, or with a clock model, where you have a tick and then you tend to look at your ring buffers to see what data you got in the last tick to put them out. Obviously, if you've got ticks, they need to be ordered correctly, otherwise you'll have a huge latency through the whole system. So, if we take a typical sort of model, we have a keyboard here, and it's connected through a key group, scaler, oscillator, there's the mixer, and the final audio. The ISO clock is driven by the audio interface. So the audio interface is getting called, it's calling clock ticked every time it needs a buffer. And throughout the system, you have clocking nodes. And these nodes actually can be passed along ports and passed down bundles. Each port can have only one clock for all its data. So all its data has to have the same clock. And on a bundle, there is one clock on the whole bundle too. And the clock nodes get passed around so that the system can actually build a processing graph. So when that audio tick happens, he ticks, he's at the head, so he'll get ticked first, then him, all the way down the chain. The keyboard, because it has an audio output, does have to have...
Is that the headphones?
Yeah. Has to have two clocking nodes, because obviously, because otherwise we create a loop which creates latency. To get zero latency, you do need no loops. The clocking system is quite primitive at the moment and doesn't deal with loops, so we generally just avoid them. Some agents, like the sampler, in fact, and the mixer especially, have lots of clocking nodes inside them because of offend send and returns and things like that. They have their clock processing is split up into lots of places so that different data get injected, the dependencies can happen right.
The other thing about this, of course, is looming in our future is multi-core support at some point, and that's going to make our execution processing graph a good deal more complicated. Is that fair to say, Jim?
Yes. Yes. The current system, I'll
Because
talk
you've got multiple connections and you've got to tick them all at once.
Yeah,
You
but
might
there's
have
mechanisms
loops.
in the multiprocessor
Sorry?
course for doing this. There's exactly stuff for doing this down at the lower level.
You're the man to talk to,
Okay.
Jim.
Yes.
It actually might be easy.
No, it's really that you've got multiple things that might well, you say that, but it's not as simple as you can imagine.
You have to make sure.
If you've got a signal that comes down and splits,
You have to make sure the
and then
data's
comes
in the
back
right
and is
place.
mixed,
So, yes.
you've got to have all that stuff ticked to the right. And there's
You
only a
have to
certain
just-
degree of parallelization that you can do in assignment to
You
other
have to make sure your
cores.
data's in the right place.
It's not a totally trivial.
Yeah. No, it's not, I didn't say it was trivial.
The way EigenD works currently is that there are multiple slow threads and one fast thread.
First, yeah.
In the slow threads are restricted so that each agent is effectively single-threaded. Only one agent will be in. Only one thread will be in a given agent at any time. What's more, all of the low-level calls, anything that could communicate with another agent, all the kind of data sending, all that stuff, they're all decoupled. The threads are basically event loops, so that when you call into the core to do something like send data, it will never call out of the core again. If it is going to make a call out, it'll always do it by dropping a message and calling another call out. So you can't get into this kind of stack twist nightmare of, you know, callbacks calling callbacks and things. It's all decoupled in the slow threads. It also helps because you don't then get the calls going into other agents and messing with the threading. The fast thread is not like that. When you put a piece of data on the queue, that will call out to send anybody who's subscribed to that data. That's what's likely to have to change if we multi-thread the fast thread. It used to be like that, but it's quite a big overhead. There are some other fast thread nightmares as well. The basic data lump we use is a normal kind of immutable data object. It's reference counted. The one we mostly use in Slowland uses atomic operations for reference counting. Even that is too much overhead for the fast thread because of the way it causes it doesn't do good things to the processor. So the fast thread, there's a version of that for the fast thread which isn't thread safe at all for the reference counting. And, biggest source of bugs we have, I think, that. But anyway, now, if you're dealing mostly with bundle components, the clocking is pretty much done for you automatically. With CFilter, bunch of inputs, bunch of outputs, you don't have to worry about the clocks, it just calls you on a clock tick. There's a variant of CFilter called UFilter, which is unclocked filter as opposed to clocked filter, which is where CFilter gets its name, where you actually get pushed the data. That's used for some things like the scaler, but in general, for most of the processing we're talking about, CFilter's the best.
In the case of clocked sources, the upstream agent will presumably be in the metadata, so I don't have to go through all the chain.
The clocks actually happen through the underlying fast data mechanism also carries the clock. They're not in the metadata. They're part of the underlying kind of linkage mechanism.
I meant essentially, if I understood it right, then it's for the clock data, it's essentially some kind of pulling mechanism. So
No, when you have a clock node,
yeah.
it essentially has a virtual function which is ticked. So you create a clock node and you do things like, someone will give you a pointer to another clock node and say, okay, put that upstream of me, put that downstream of me, and then it will just call the ticks in the right order.
So you just implement the tick operator.
You implement a clock
You're just
node, it gets hooked up, and then
guaranteed
it will be ticked.
So it's essentially a feature of the that I'm providing a clocked output, not that I have a clocked input.
Practically all inputs have clocks on them, even if it's the aniso clock. There are rules about what clocks can go upstream and downstream of other clocks. Essentially, the aniso clock can go upstream of anything. So, in this case, when the ISO audio clock ticks, it will cause the aniso clocks to tick in the right order at the same time. It's just that the aniso clock is allowed to tick more than once per. It can tick whenever it likes, basically, because it's aniso. So sometimes it will get ticked twice for one audio clock tick, sometimes none at all. It just depends, really. But you don't. The only time you'll have to worry about clocking is when you're doing things like merging data from two inputs, which will obviously have different clock sources. Correlator does most of it for you.
So you're only using one tick call to represent both ISO and ANISO. It's not like you have two separate implementations, two
no,
different names. You know.
There is actually, the ANISO, there is one ANISO clock internally which does tick by itself,
Right.
With a kind of nominal 10 hertz or 100 hertz clock rate, something like 100 hertz, I think. But
But a single agent has a single clock. You can't have two clocks. You can't have an ANISO clock and an ISO.
yes, you can.
You can.
You can. I mean, there are just clock nodes that you can have as many of them as you like, in whatever clocking domains you like.
But a bundle, for example, always is the same.
Yes, there's
Yes,
only one. There's only one
it's
clock
one
on a
set
bundle.
together. I
Different
understand.
bundles,
Well,
different clocks.
If you imagine a bundle as a set of
Doing the same.
set of components in a graph, it's
Yeah.
actually each line in the graph has a clock. So you could actually have different clocks on different lines in the bundle, and it's up to the thing in the middle to pass the relationship on, which C-filter will do for you. C-filter is itself a
That
clock
could
node.
see. I think I see what you mean.
It's
I see what you mean. Yeah. Now I got you.
the correlator at the head actually has clock node, and then each input it just puts upstream of its clock node to make it tick right. So clock sources, yeah, that's what we sort of talked about those. In general, the clock source there's the default isochronous clock source, which is set by the audio agent. One day we will support multiple ISO sources, but then we have to deal with the fact that if you put one ISO upstream of another one, you're going to have to resample. Which could get heavy. Also, if we go into proper networking and actually putting ISO over the network, you'd have to resample all the time. Although you don't want to, or at least buffer. You have to do something anyway. All right, finally. So, yeah, our agents that aren't plugins are, obviously they are really plugins because we plug them into EigenD, but only in the sense that a program is a plugin to an operating system. This latest release, what we've all been beavering away at, is we've refactored everything so that you can put an agent. Agents live in self-contained directories. So you can compile an agent up, zip it up and give it to somebody. They can unzip it and run it in their EigenD.
It's binary.
As binary. We haven't got any versioning yet, so at the moment it'll only, your mileage may vary if you put it into a different EigenD. But we're going to be working on that. Also, we've factored out the build systems and stuff so that you can build an agent without the source. You can build it against what's installed with EigenD 2.35. So there are headers and libraries. We also put a copy of the build system in. You have to copy it out into your build tree. You can't run it in place at the moment. Which isn't such a bad thing because on Windows it's hard to find anyway, depending on where it goes. But and the build system will even build an installer for you. So you could, if you build an agent, you can just zip it up and it'll. If someone installs it, they'll have it in their EigenD. So we're hoping that we can get. It'd be nice if we could get a bit more of a market and a sharing of weird and wonderful agents going.
There's no reason this means that you'll now be able to write and, if you choose to do so, sell. So you could do closed source agents and sell them. And if we get enough activity going on in that area and people are interested in it, we might put a marketplace together on the website for that. So I'd really like to actually start to kickstart some sort of ecosystem, both in free software and potentially in stuff for Luca for money.
So can I go back to ask a question about your clocks?
Mm-hmm.
You're not doing any kind of guaranteed scheduling. You're not guaranteeing that all processing will be done within a clock tick.
No.
And there's nothing that's sort of.
No.
You just
We did look at that.
We're going to write stuff that will do it right.
Yeah, we kind of bogged down in trying to do that.
Yeah. No, it's
not
very
easy.
complex.
It's easier just to do it right, actually, and not overload
Is
it.
it clear when the errors are occurring?
You get horrible noises.
Yes.
Yeah, that's one way that it's pretty clear.
horrible noises.
There are some measurements. So if a clock tick takes an outstandingly long time, then it will generate a message.
Yeah, but generally because your ISO is driven off your clock, therefore
Yeah.
you're not getting that.
But you get a glitch. You just get a glitch. So.
But also each tick. But it has to be quite an outstandingly long time to generate that message. You know. I mean, unfortunately, because the system is still, you know, there's lots of stuff that the communication between fast and slow threads, because you're not allowed locks, obviously, and stuff like that. There are some common tools we use for communicating with the fast thread. One of which is obviously because they're all event loops underneath, is just to inject an event into the fast thread and wait for it to get done, and then wait again. You know, that's an easy way. Depending on, you know, when you're plumbing, you get more or less of these things actually happening. They tend to be quite low priority, so the system tries to spread those out a bit.
But you could easily build a configuration with the current set of agents, which would exceed the time.
Oh yes.
And fall apart.
Yes.
So it's not nothing. You're not even. Yeah. Okay.
People routinely do it. Just that's when it glitches.
But yes, I mean, it would be nice to. I think at the moment our resources are probably better spent multi-threading it to get more horsepower out of the hardware we've got.
I absolutely agree with the approach. I just was trying to figure out what level of complexity you're coding.
Yeah, well, no, we did kind of look at that, and apart from a lot of things, it's very hard to specify in advance how long a given clock tick is going to take. You know, if you want to give me a list of, put the song in first so it can analyse and
what it might sound like.
then we can distribute the fast thread or something like that. It's
Well, there's two principal mechanisms, Jim, aren't there, for passing data between slow and fast. There's flip-flop and...
Well, there's this fast call, which is basically running a function in the fast thread and waiting for it to happen. So then it'll get slotted in with the fast
throw
thread.
it over and wait for it to
There are some fundamentals for just kind of passing messages, really, from one to the other, you know, sort of asynchronous messages. Also, we have a thing called a flip-flop, which is a dual copy. The slow thread can maintain something, and it actually has two copies of it, and what you do is you exchange the copies.
I've seen the flip-flop
And
mentioned in code.
yes, so the idea is the fast thread can guard it. The idea is there's always one copy is available, even during the sleight of hand operation. The fast thread can essentially lock that one, and then if the slow thread tries to exchange copies underneath, it'll wait until the fast thread has actually released it. But the fast thread always has one. But the limitation of that is what the fast thread sees has to be read-only. That's the thing. But for a lot of things, like if you're building a clocking graph in Slowland that the fast thread's going to do, then read-only is fine. You know?
So essentially there are only two copies, so the copy accessed by the slow threads, if there are several, has to be locked.
You can have as many fast thread accesses to other read-only accesses to it as you like. Actually, I mean, you have to use mutexes or something to mediate access to the slow side, but there can be as many read-only ones as you like.
Do you know when the flip-flops pass? Do you know that it's in the norm?
Yes.
You could set the value, and your workbench could say it's 23, but it's using 5. Do you know at the point where
It's an explicit operation, so
Yes.
you can change
There-
multiple things and then say...
You have an exchange. So supposing you're flip-flopping, I don't know, an array or something, you can muck around with the backup copy of the array, and then you do an exchange operation, which changes over.
Is that kind of a
When the exchange,
is it like a set of values?
well, it'll exchange the value. I mean, the value could be an STL map or something like that. I mean, it can be anything.
Oh, so you can put.
I mean, it just exchanges 2 pointers.
Okay.
Yeah, you can use anything you like. When the exchange returns, you're guaranteed that the fast thread is no longer using the other. So it is deterministic in that respect.
Yeah.
Okay. Anyway, that's it. I'm done.
Thank you.